In this next segment, we're going to talk about doing some site prep, whether that be dirt work and setting out your footprint. We're also going to talk through a couple of different methods for setting your ground posts and some of the things you need to consider when you go to set your ground posts, whether that be spacing or the type of footing you want to use.
When you're considering a location for your tunnel, I think it's primarily up to the producer and how they're going to run it and what the long-term plan is for the garden. I mean, everybody's going to have a different, sweet spot in mind. For me this year, we've had a lot of rain. I will say, one of the big things to consider is the drainage. That's making sure you're at the right elevation, and that probably will segue into the conversation about what's required as far as dirt work and leveling and all that stuff. So very, very farm specific. Knowing what you need is probably the most important part.
We built a tunnel here at SDSU, not this project, but a previous one, and we built it at grade. And we found out why that, at least on our site, was a bad idea. Is what we ended up with is the natural drainage of the site would cross through the high tunnel. And there's baseboards, hip boards on the bottom, or baseboards on the bottom, and it creates like a dam inside the tunnel. And so your tunnel ends up staying really wet just from your irrigation inside. But then you were also getting water kind of runoff. So with this particular project, we built the site up about a foot for each tunnel from the surrounding grade, because we didn't really want to repeat that, because it is really difficult to raise the grade after you've already built the high tunnel. So it's definitely something to get right the first time.
At my farm, I have a lot of hills, and finding a flat spot is kind of a challenge. And so I had to look for a spot, well, where can I minimize the amount of dirt work that I have to do to get this flat? I had to lower a couple feet on the one end and raise a couple feet on the other end in order to get a flat enough spot.
See, and I'll be honest, like for us, we don't do any like grading. I set my post tops level and I just let the ground do what it does. Yeah. And then I take the laser and I check the fall from one end wall to the other end wall, because I want to know what that is. Yeah. I don't necessarily care what it is, as long as it's within a few percent. Right, like 2% fall away, I don't care about. But like
inside the tunnel.
Yep. From one end of the tunnel to the other end of the tunnnel.
So you're focusing on your grading inside the tunnel to move water then, or you're trying to get it as flat as possible.
No, I'm not actually doing much grading. For me, I've found that grading. This is in our context. That grading does so much compaction damage to the soil, which then prompts bindweed and thistles, which are the two worst ones to deal with, that I would rather not mess with the soil in there. Because I've done some tunnels where I did the grading and some tunnels where we made the tunnel itself level and flat, right? And we just set it, and the ground is inside it is whatever the ground was already. And for building the tunnel, as long as your posts are level, like the ground doesn't really matter. As long as it's within a couple percent, sure. Right? If you're on a 10% hill, like, yeah, you want to figure something else out.
I see what you're saying now, yeah.
But I mean, I think a lot of times people get hung up on this, like having to do the dirt work thing. And that's great for those of us who have the knowledge or experience or access to equipment to say, oh, I'm just going to grab someone's skid steer and I'm going to do it in a weekend, right? But for people who aren't doing that, like people get very hung up, it seems like, on like, well, I need a perfectly level space. You don't. Like if stuff grew there without a tunnel over it, it'll still grow there with a tunnel over it. And yeah, I mean, drainage, like water is an issue, but water is always an issue. Like you still have to, you're taking all this rainwater and you're collecting it in a very concentrated spot. Like you've got to figure out how to address that.
Me, my first one, I had good black dirt there. Yeah, and that's what I built on. It was kind of level, but we still had we brought a bulldozer in and leveled it. But my second tunnel, we brought 2 feet of black dirt in. Yeah. I mean, just to try and get the drainage right, so.
Depending on how you operate it, you may not need electricity, but you pretty much need water. There's not going to be any question about that. And so you need to be at a location where you can get water to this structure and where you can reliably get that for the time of year that you're going to be growing. So you don't want to be dealing with a hose halfway across your farm that's going to freeze up in the spring or the fall when you have to be watering plants. One of the hot topics that's often divisive with high tunnels is what direction should you orientate it? Should the long direction be east to west or north to south? And I've been doing a little bit of digging into that, and the answer is it doesn't make a lot of difference. There are a lot of different wives' tales maybe that you would hear of, oh, this is best, that's best. But in reality, you don't get more heat to your high tunnel, whether you do it north to south or east to west. There have been some really good studies looking at light falling on the plant canopy. So if you're growing tall plants, like tomatoes would be, where at the peak of the season, they're maybe 6 to 8 foot tall, going east to west will give you better light to the plant canopy. Whereas north to south, the south side of the rows of the plants will shade the rest of the row. And so generally for long season growing or early season growing, east to west is going to give you better light to your plant canopy. But as far as heat to the structure, it's about equal either way.
Have you found anything that would say ventilation would be easier north to south, east to west, or is it all strictly just sunlight and heat?
Yeah, I think that's a good question. The studies and papers I've seen, they didn't find a difference in ventilation. I think some of that's because wind is pretty unpredictable. Like today would be a great day for ventilation, and we don't have any breeze. So it's not going to matter where your vents are if there's not a breeze. And then sometimes when the derecho comes, it comes from the opposite direction of what prevailing winds normally come from, and that's tough. So I feel like betting on the wind and the ventilation is tough to make a rule of thumb for. But I do think you have specific site conditions that will affect the wind. So maybe I've got a shelter belt on this side that is protected and you're not going to get airflow from. And those could be good factors to consider. Maybe you have a barn on this side, and so that's things I think would play a role into that.
Well, I would agree with Shannon that the wind always comes from the side that you're not really protected from, right? So we've lost tunnels. We lost a tunnel that was oriented east-west. We lost a tunnel that was oriented north-south. We lost a tunnel that was oriented north-south from the south. So you lose tunnels from all kinds of directions, depending on where the aggressive winds come from. For me, all my tunnels run north-south now, not for any purpose of scientific reasoning or ventilation or anything, but just because I built the first one north-south and I want them all to look the same, because you don't get a lot of uniformity on the farm, and some things you can make uniform.
If you're gonna have multiple tunnels, or if you got other buildings or tall things on your property, it's important to think about the shadows that those things cast, and not the shadows that they cast in the summer, but the shadows that they cast, all through your extended growing season with your high tunnel. And so there's tools you can use online. We just used like a free version of SketchUp even to model how far that shadow went, and then space it appropriately. Give yourself a little wiggle room, don't come right up to the shadow in case your measurements are a little off, but that's how we space these.
Yeah, and I would agree. Like we've got ours spaced 8 feet apart because I've got an 8-foot bucket on the tractor, and so at least on some of our tunnels, right? Because I want to be able to clear snow if we have to. But for me, we talked about siting and flat spaces. I would rather maximize how much of my growing space I can get covered, because the space between tunnels does often end up being like an unused space or harder to use as a practical growing area. And so I'm also experimenting, right, by saying, well, we'll see how much we lose, right? Because at that point, you've got 2 layers of plastic, and so it's similar to like a double layer, right, as far as how much the plastic holds back. But we'll all find out.
Yeah, so it's kind of a balance between maybe I lose a little productivity in the tunnel, but I don't have this huge waste of space in between the tunnels.
Yeah.
You maximize your square footage.
Yeah.
You could probably easily find it in the maximized square footage, I bet. But there again, every farm is different. I think we'd all find a different answer if we looked hard enough.
That is one of the things that I thought about when I was locating my high tunnel, is looking at where do I get the most sun exposure throughout the growing season. And that did play into where I put it, and it played into the trees that I cut down to help it grow longer. So I use an app on my phone. I think it's called SunPath. There's a few of them out there, and it's really fun. You can take your phone and you can stand at, say, the south corner of where you think your high tunnel will be and hold the camera up, and it'll draw across your sky where the sun will travel across the sky. So you can look and see, oh, this tree is going to be in the way in December, but I don't care, I'm not growing in December. But come April, that tree is going to be shading my plants. And so then you can, if you want to get rid of that tree, you can. So I think that's a very valuable tool that I've found is helpful. And sometimes I've noticed that people don't realize how much of the day is shaded for them in their location. Right now, we wish we had more shade, but it's tough until you do that. Because I had one friend that was like, I want to put a high tunnel in my yard. And I'm like, I stopped by and I took a picture with that app, and it's like, you get 2 hours of direct sunlight between these trees. So if you want to do this, you want to do something about those trees or find a different location that you're not going to run into that issue.
One of the big things we have to worry about here is wind. So I would say, strength is probably one of your biggest considerations. How am I going to make this thing stand up against a 50, 60, 70, 80 mile an hour wind? And more posts is going to be better. The more anchored in the ground it is, the better it's going to be. There's probably other parts of the country where 6 foot spacing is plenty adequate. But for us, I would recommend 4 foot. It seems to, you add a few posts, but for what you gain in strength, I think it's worth the added effort and the cost associated with it.
For us on campus, we decided to just drive the posts in directly. And so these are not on concrete foundations. This is a 9 foot long post that's been pressed down. We did this with a skid steer. You could do it with really any large piece of equipment. This is my visual aid here. Obviously our posts are a lot bigger and they're up in the air, but you're putting basically the bucket or whatever you're pushing down with this post on top of it. And then you're just pressing it into the ground. So we're fortunate there's not a ton of rocks in our soil in this location. And so we were able to do that. If you're in very rocky soil, your mileage may vary on trying to just press those directly in. These are about 4.5 foot in the ground. And so, yeah, that's pretty standard for us here on campus for other structures of this type. I will say one important thing is getting the post straight and then getting the measurements perfect, or as perfect as you can. So you need to know if you have a 30 by 96 high tunnel, and others may disagree with this. You want to know, is 30 from the outside of post to outside of post, or is 30 from the inside, center to center? Try to get all that stuff as close as you can to perfect. These structures have a lot of wiggle room in them because they're a kind of a loose structure. And so if you keep kind of stacking these tolerances of, I think this will be close enough, eventually you're going to end up to a point where things aren't quite matching up. So it may seem silly to try to get it so perfect, but it really is, as we found, kind of important. So just going to get down here. When we're putting our posts in, we want to make sure that they're level. Because if they go in crooked, that is going to mess with the spacing on the hoops. There's a couple of tools you can use for this. You can use like a 4x4 post level. This is great because it levels in 2 directions, right? It's got levels on both sides. So I can make sure I'm level in 2 directions. This works too, or better yet, if you have 2 of these, you can level in 2 directions. I'll say setting the posts takes 2 to 3 people, a couple to hold, and then one to kind of drive things in. You want to be very careful as you're pressing these posts in that you don't get them too low. Too high is okay. We can work with that. Sledgehammers can do a lot of work. It's surprising. If you get them too low, it's very tough to raise this back up. And so that's when you're starting to get within a couple of inches of the height that you need all your posts. You want to start slowing down with whatever piece of equipment you're using, or maybe even plan on finishing that last inch or so with a sledgehammer.
One thing I would recommend to anyone is to use a laser transit for site prep. You can eyeball a piece of ground and say, oh, it looks pretty flat, but actually the human eye is pretty easily deceived as far as what flat is or how flat something is. And so for me, when I go to build a tunnel, the first thing I do is I shoot all 4 corners of the proposed tunnel with a laser transit and a receiver, right? So I set this shoots a laser out in a perfectly level line all the way around. I think it goes up to 150 feet in any direction. And then I take this receiver and I put it on a measuring stick or a surveyor's stick, and I check how, like to the level of the line to the ground, what the distance is. And by doing that, we're getting a good, clear image of like what our ground is actually doing, what the slope of the ground already is, if dirt work is required, or if we can get away with just putting in posts as it sits. This is a tool that is pretty specialized. I have one because of some other construction work that we do on the farm. I will say these are easy to rent from home improvement stores or from rental companies. They often have a laser transit available because it's a very nice piece of equipment to have for these kind of jobs. So on our farm, we use concrete on all our posts. We lost the tunnel once upon a time because we didn't concrete the posts in, and so ever afterwards I've concreted the posts. We have purchased an auger for our tractor. Again, an auger is a tool that you can rent. So we do the same starting technique that they are doing when they're driving the post. We find the 4 corners of our tunnel, we make sure that they're square. You can either do that with a fancy laser, or you can do it with just 2 long tape measures. Make sure your tape measures are longer than the total length of your tunnel. So if you're doing a 100-foot tunnel, you'll need a 110-foot tape measure. For us, we did a 150-foot tunnel, so we needed 165-foot tape measures to make sure we had enough to go across the diagonal. Once we have the corners set, we pull a straight line from one corner to the other corner down the side, and we generally do that with the same tape measure. And we mark every 4 feet if it's a 4-foot spacing tunnel, or 6 feet if it's a 6-foot spacing tunnel. You take paint and you make a little dot on the ground. I would recommend to everyone, before starting to set out your site, rototill the 2 sides of your tunnel where you're going to be working, so you're working with some soft dirt right on the surface and you're not dealing with grass or long weeds where you're trying to set your posts and dig in your baseboards. Once we have the site of the posts marked on the ground with paint, we come through with the tractor auger and we auger the holes. We try to go down at least 3 feet. 4 feet would get us below the frost line here in South Dakota, but our auger's not that long. And to be honest, because the entirety of the structure is not subject to differences in the heat, it's not as critical. If we get a little bit of frost heave on our post, we're not too concerned about that. 3 feet seems to have been enough so far to keep the post from coming out of the ground. We're generally augering either an 8 or a 12-inch hole to set those posts in. Once we've augered all the holes, I actually come back through with my baseboards and I connect all my baseboards together and I set those on wooden ground stakes. And I'm pulling a string line from one end of the tunnel all the way to the other and then adjusting the height of my baseboard to be perfectly level all the way along the length of the tunnel. Once I have the baseboard in place and stabilized with ground stakes, I bring the posts and then I attach them to the baseboard with the post clips that come with the kit to attach your baseboard afterwards. So I essentially am hanging a ground post off the baseboard into an open hole. Once we have all the posts in, we check it again with a string and with an eye to make sure it looks pretty level. Then we come back and we dump the concrete into the holes as we walk along. After the concrete's in the holes, then you do one final check, particularly because you need to make sure that the posts are not leaning in or out. Right? We can check them for level end to end or plumb end to end, but leaning in and out changes when you pour that concrete in there. So you come back, you adjust them in the wet concrete before it sets, and then you walk away and let it set up overnight.
All right, so there's probably like 3 different ways that you'll be able to do the pipes. We talked about the standard pipe. It's called, usually they'll sell it as a ground pipe, and that's pressed in. Some companies offer what they call a ground stand, and that's like this, where they have a plate welded on the bottom. So when I was building mine, it was shortly after we had experienced a derecho in South Dakota where we had 90-mile-per-hour winds. And my parents have some hoop buildings, and I saw their pipes that were buried 4 or 5 foot in the ground, pulled right out of the ground with that. And so one option you can do is concrete in these pipes, and then that's going to give them much more rigidity so windstorms can't pull those out of the ground. But once you start adding concrete to your structure, that typically changes how it's categorized for taxes and permitting. And so if you use concrete, it will often be considered a permanent structure. So then when they're doing your property taxes assessments, this might be included in your property taxes. Whereas if it was just pounded in the ground, it's not. Also, Tanner mentioned that you need to look at your local requirements, and also one of the reasons they pounded in the ground. But I think as soon as they would have used concrete, then it needs to go through permitting and a much more complex process, because it becomes considered a permanent structure versus a non-permanent structure. So some companies offer these ground stands, which give you kind of an in-between of the two. So unfortunately, you can't pound this or push this into the ground. You have to use the method that Dirk said, where you dig with your auger or your post hole digger, first a hole, and then you set this guy in the ground. And with this plate on it, when the wind comes through, it's not going to pull it out of the ground, but yet you also don't get considered to be a permanent structure like if you use concrete.